GM everybody. Welcome to today's session. So this is going to cover some of the tests that were failing in the previous session where we covered front-end integration. So the version of what we have is kind of not consistent with the test, and that was why it was failing. So I'll be covering that with the hopes that all of what was taught in the last front-end integration will be covered in this test. So in the last session, we were exposed to Stack. This is the contract, and in this contract, we saw that we were exposed to an extra function in our interface, in our threads. So we had gateway number, and we also were interacting with the ERC20 token. And we kind of like specified that we were referencing a live stack token on mainnet, right? So, and this kind of like caused some changes to the tests that were failing. And in this version, I will cover the tests that will make this contract to pass, and we'll have no such issues. And kind of like a tweaked version of what we have covered in the previous session, and how we can actually test fork testing. So you remember in the last session, I mentioned that fork testing is it simulates the state of a specified real network and performs actions on it. So basically, you want to take a snapshot, it kind of like take a version of a real network. In this case, it could be a mainnet or it could be Sepolia. But in our case, we're going to be working directly because of this contract that is live on mainnet. We're going to be working directly with a live mainnet version. So yeah, so this is kind of like how fork testing works, and we'll be covering how it works in this session. So yeah, so this is kind of like a snippet of our tests. So this is kind of like a snippet. We have more specified these attributes, making sure that we are referencing the RPC URL and the block tag. So without this, the test runner will not acknowledge that this is a test that is supposed to fork the real network. So yeah, so like I mentioned earlier, the actions that are performed are not real on the network, on the main network itself. It's kind of like on the forked version, right? And this is a typical example. We've seen that we want to integrate an ERC20 token, probably one we want to stake. But in our own case, we'll be seeing how we will integrate it for approvals and for getting balance of a given account, and basically that. And that is what we're going to be covering in today's session. So yeah, a simple walkthrough. So this is what we was added. So we were referencing a this is Stack Net's token on mainnet. So yeah, so it's the same thing, the same contract address. When you come here, you can see the top holders of this token. So I can share more, I can actually increase this. So yeah, so this is referencing all the top holders of Stack token, right? So this is Stack token on mainnet. So basically, we'll be using this in our tests in this session today. So yeah, so covering some of the things that changed. I think one of the things that changed is we kind of noticed that in our contract, the increase counter in kind of like was changed. So we have a different logic outside what we covered in our last session, right? So we only read the current count value and increased it by 1 and emitted that the increase event. But basically in this new version, we're saying that every time a new value gets to 10, like this win number is our win number here is what we're looking at, right? So win number for us in our case is 10. We've set it to 10. So when counter reaches 10, caller gets all the stack. So yeah, so we're saying if the counter value is equal to 10, we should perform all of the logic within this if block. So right, so we're referencing the caller address, we're getting the stack. We are converting this the file 252 value of our stack contract to, we're converting to an address. So this is basically how we do it. We're trying to, and we unwrap, and we have a reference that serves as the contract address of our stack token, right? And we kind of like use the dispatcher to passing the address that we have to give us an instance of this contract. So basically that, and we're checking the balance. If this contract has some stack tokens, we should proceed to perform this line, the logic here. So the logic is saying that if balance is greater than 0, we should proceed to transfer all of the stack tokens, right, to the caller. So anybody that calls this increase counter function when counter value is 10 should get all of the stack tokens in this contract. So that's basically what we covered that was what changed in this contract. So yeah, so and also we have the set counter where we kind of are saying that anytime we have a balance that exceeds 0, so anytime we have stack token and somebody attempts to reset the value of the counter state variable. Remember, we have a counter state variable, which is this of type U32. When somebody attempts to do that and we have a balance of stack token greater than 0, we should take from that person's stack balance, right? And send it to this counter contract. So the entire value of the stack token balance of this contract. So the person should send that amount into this contract for them to be able to reset our counter to 0. So basically that. So all of these are what changed, and we're going to be testing them. So yeah, in our test file, so basically we're going to be covering some things that will make this test to work. So one of those things we're going to be implementing. We're going to be importing some libraries where we're going to be having our OpenZeppelin libraries. So we're going to be having the OpenZeppelin token. So this gives us access to the interface, which in turn gives us access to the dispatcher and the dispatcher treat. So dispatcher is what will wrap an address into it. And this dispatcher treat enables us to call the methods within the dispatcher. So we have all of the methods that makes an ERC20 token and ERC20 token. So we have name, total supply, decimals, balance of, like all of the things that make an ERC20 token function as a token. We'll have all those methods because of this ERC20 token dispatcher treat. So that's that. I think the next thing we're going to be doing is we're going to be creating a reference of our stack token. So I'll be doing that. So probably to make things a bit faster, I will kind of like have to copy and paste. So basically some of the things that we need to do. So nothing more than scrap FMT, making sure that my code is clean. And I'll clear this. So basically we have a reference of the felt value of that we kind of like specified in the counter contract. So this is the felt value, the stacknet. So yeah, and we're going to be converting this felt to an address. So that's basically what we're saying. We get this by importing it from our counter. So our counter is going to give us a reference to this felt stack contract, right? That is of public. It's a constant and it's public, right? So we have access to it in our tests. So this address, we will convert this felt value, right, to an address. So basically, this of felt type we converted to an address by calling it like this. right? We're trying to then unwrap. So that gives us access to a type called contract address that we can actually use in our test. So yeah, so and in the live network, remember I mentioned something that in our fork testing, we're simulating the state of a specified real network and perform actions on it, because we cannot in our test, we cannot perform certain actions directly on the live network. So to enable us to do that, we have certain things that the scarp.toml file will be looking out for. So one of those things is the fact that if we run this test now, it will fail because we have not specified that we need to have a mainnet test. So this is how to specify it. So have mainnet test, and then we convert this to what? Mainnet. So yeah, so this is basically we're telling the test runner to look into this scarp.toml file and enable us to fork the network, right? So the name is mainnet. The test can call it anything you want, but for us, this is the convention, right? So, and with the RPC URL, if you have another RPC URL, probably from any other provider, in this case, we're using Blast API. So this is the provider, and this is the block ID, right? So we're referencing the latest block per time for every test. So yeah. So so pretty much that. So we're going to be, we set up the accounts that will be enabling us to perform our tests in this session. So yeah, so one of the things that we'll also be using is we're going to be, I think some of the things will fail, but we'll fix them shortly. I think we're going to be referencing this ERC20 token dispatcher. So yeah, so you can see a lot of squiggly lines here. All the tests that we have so far are yelling because our deploy to function is expecting 4 return values, but we are specifying only 3, as the case was in the first instance. So I think we're going to have some things here. So we will have to simulate that every time this contract is deployed, we will have to do something. So yeah, so we're going to do something here. So yeah, I think is yelling at us because it doesn't know what stack token is. So we're going to create our stack token. So we're going to say let stack token equals to ERC20 dispatcher, and we're going to specify our contract address, and it's going to be of type. Remember, it's going to be of our stack. So yeah. So yeah. So this is how we simulate we initialize an instance of our stack token. So basically this. So the next thing we're going to do here is to ensure, I think we will ensure that, so we'll have to ensure that, so this basically explains some of the things that we have to ensure. So it's kind of like yelling at us because it doesn't know what stack amount is. So I can actually create this here and then say let's const stack amount equals to of type U256, and it's going to be let's say 5 stack. So you can actually like that. So equals to this is 5 stack. So I think so I think the way we do it is to specify that the 5 stack in this case is going to be 5 decimal, so 5, which is the value, and it's going to be 18 decimal places, like yeah. So because in our stack token contract, we have that the decimals is 18 decimal places. So in our own case, we're going to say 5, which is the value of 5 stack, then this is 18 zeros. Yeah. So basically, this is how to depict 5 stack tokens in our test. So there are other ways you can actually import Alexandra's math library from Scarp, right? The Scarp registry, and then you can actually use that. But we want to keep this as simple as possible so that it's kind of like clear for those of us who really want to follow along. So yeah. So yeah, so since we are interacting with the mainnet token, we have to simulate a transaction coming from an account that has some stack token, right? So we don't have the private key of this address. So this stack holder, it could be any address. Just what I did was to go to, I went here and what I did was to kind of like on the top holders, I think any account here can actually work. You can actually copy any wallet here and basically use it for the test. So we have kind of over 553,000 holders, any account you want to simulate. So basically that. So basically what I'm doing here is to come to the Explorer, any account. It must not necessarily be this account. So I just came here and I'm seeing this account and I see that this account has over 7 million stack tokens, which I want to use for test. So basically it could be any account. So yeah. So this account here, this is the account here. So copy that, and it's going to see it as a file 252. But we need to convert this file 252 to an address, right? So a contract address. So that's how we do it. We're passing this reference, and then we're trying to unwrap. So this automatically converts this stack token holder address to a contract address that we can actually use in our test environment. So yeah, so that's basically what we did. And then so like I mentioned, we are not performing any state change on the network directly. When we fork that net with the network, it gives us access to certain all the states, like it takes the version of the state, and then we can actually perform actions on that fork version and not on the real network. So yeah, so we want to take a fork of what is happening in the network, and that should give us the access to all of the account balances and all of what has happened, especially within the block, like right, a given block that we specified. And we want to simulate that, because in natural sense, what we're trying to say is we want to simulate this fellow here that has this amount of stack tokens, but in this case, we don't have the private key in the test environment. So what this will do for us is to, when we call this, when we call this, so basically when we call this static caller address, it's kind of like going to mimic this folder in real life and give us access to that this account contract, right? So this is an account, so we can actually use this account to perform some transfers. So for this test to work, remember the logic of this contract states that whenever you want to increase counter, there's this line here that is this logic here stating that whenever count gets to 10, we kind of like transfer all of the balance. So that means at some point this contract was stack token was transferred to this contract, right? So yeah, so we're going to simulate that in our deploy util function. Remember, our deploy util function will enable us to perform certain that is, anytime we want to deploy our counter contract in our test environment, this function will run before it gives us access to all of the returned types here. So all of these types, we'll have access to them. Then we'll have a possibility of testing accordingly in all the test cases in this session. So yeah, so basically how it works. So we're going to transfer. So now we are posing as this stack token holder, which as at the time of recording has over 7 million stack tokens, and we're going to transfer all of, so we're going to transfer 5 stack amount, which I earlier specified here. We're going to basically transfer this amount, that's 5 stack out of the 7 million balance. So kind of like ignore all of these squiggly lines, we'll fix them. We'll transfer that 5 stack tokens to our counter contract. So when we do that, the next thing we're going to do is to stop calling the stack token contract, and then we return all the values, right? So yeah, so we're returning an instance of our deployed counter, enable, save dispatcher, and our stack token, right? So yeah, so this is what we're doing. and then we're good. So our deploy contract is ready. So we collapse it. So now all of these issues we're having here is as a result of the kind of like extracted value from this deploy util function. This deploy util function is returning for, so when we see it over here, it's returning these four types. So it's returning all of the dispatchers that we'll need in our tests. So we have to kind of like extract them out. Currently, we're just extracting 3. In the last session, which was the case, but in our own case, we're going to be extracting more than 3. We're going to be extracting 4. So all of those squiggly lines and the error messages will go away when we extract accordingly. So yeah, so let's do this for all of them. So we can actually run our first test now. So basically, so yeah. So yeah, I think we're good to go. So that means all of these squiggly lines gone. So right now we're good to go. So now the first test will be to test what happened when we deployed our contract. So we're referencing only 2 state variables, right? In our own case, we're referencing the counter state variable, and we are referencing we're also referencing the ownable, right? We want to make sure that these state variables were correctly initialized, right? So we want to have to test them. So let's test our test counter deployment to make sure that these values are kind of like anything we pass into our deploy. In this case, we're looking at 0 count. We covered this in the last test, so not going over it again. So just the only thing that we're going to add differently here is the fact that we're going to be adding our attribute, right? So our fork attribute, we are going to specify, remember, we're going to specify these. So we're going to specify this, and we're going to specify that our block tag is latest. So yeah, so it's going to yell at us, but let's ignore that for now. And that's all we're going to be doing. So why are we adding this? Because we are in our deploy util function, and also in our contract, we are referencing an instance of a deployed stack contract of a stack token, right? So this stack token is what we're trying to like target whenever we want to deploy our contract, such that we deploy it and we're transferring all of these stack tokens we're transferring 5 units of stack token to our counter contract. So basically that's what we're doing here. So I will run this and let's see how it behaves. So I will always run my scamp fmt and I'll do forge test. So I'm going to test counter deployment. So basically, let's see how this works. So I think I should minimize this so yeah, I can actually see well. So yeah, so while we wait for that, I will also be going through the logic here. So like I mentioned earlier, we have this blueprint which now includes a get win number. So basically that we will be looking at the state changing functions of this contract. So the only thing that changed much was the increase counter and the increase counter, which is this, and then the decrease counter nothing changed. So basically, all of our tests just a little tweak, and this right here. So we should be getting ready to test this. I think when we test this, I think we're good, and every other thing remains the same. So basically that. So yeah. So it's taking some time. So yeah. Oh wow, I think there's a problem with something I'm doing. I probably have to reference it appropriately. So yes. So maybe I'm getting it wrong somewhere here. So, oh yeah, it's supposed to be not tag, so just block ID, right? So block tag, sorry. So yeah, there was no need for tag there. So just run this and we should be fine. So yeah, so apologies for that. So that's not equals to either. So it's supposed to be this, yeah. So this should work. So it takes some time. Remember, I mentioned earlier in integration tests, kind of like they take some time to run. Integration tests, fork tests, so a mixture of both. So we're covering that in this session, and we can see that in our unit tests, they are kind of like tested. They're fast to run. Integration tests, no, not end to end. So we're looking at integration tests, so kind of like slower to run. So that is what we're kind of like experiencing at the moment. So yeah. So yeah. So basically how we test. So taking some time, but eventually it will come out fine eventually. So um definitely taking so much time, so I can actually do SN forge in cache, clear my cache, and run the command again. So let's run the command to test this first case here. So we have our counter deployment. So yeah. So basically when we're done, we'll go to the next test, then we kind of like refactor the test case to capture the realities of the increase counter and reset counter. So decrease counter basically is going to stay the same. So yeah, so while we wait for that, also make sure that in all of what you are doing, you have specified this in your scarp.toml. Scarp.toml is your configuration file for your contract, right? So this is the first point that SM4 will be looking at the test runner to make sure that all of the configurations you specified is appropriate. Otherwise, it will throw some errors. So basically, you want to make sure that these parameters, these configurations are clearly specified in here. So this tool.sn fork enabling us to fork the mainnet and this sn fork. So this kind of like gives us access to two different networks. In our own case, we have Sepolia and we have a mainnet in our own case. So yeah, so while we wait for that, so it passed. So yeah, so that's great. So we will be collapsing this, move on to the next test. So basically what I'm going to be doing is just copy this attribute and I'll be using that to test the next function, which is the test increase counter. So basically nothing's really happened. So we want to make sure that you call this count increase count and it increases by 1. So nothing really changing, but we're going to kind of like test all of the logic that ensures token transfers, right, from the contract to the caller. So we're going to do that shortly. So let's test this before we proceed to. So we're going to do, let me clear this. We're going to do SN forge test. So we're going to test what? We're going to test test increase counter. So yeah, so basically this. So yeah, this enables us to test all the time we will be interacting with the network. We must specify this attribute. Otherwise, the test case will not be considered a valid fork test and it will fail. Because we are in our deploy util function, we're referencing this stack token, right? It gets to here, it's confused. It will not understand what you intend to do, and it will fail. Because we want to, at every point, we want to test any given scenario. We want to make sure that our contract is funded with 5 stack tokens. So that's basically what we're doing in our deploy util function. And if you check this, we are deploying, we're calling the deploy util function that we have created here. And one of those logic in this case is to kind of like pose as this token holder and transfer 5 stack token to the counter contract and then basically return the stack token instance. So yeah, so it will fail if you fail to fork the network. So yeah, so basically one of the things that is worth mentioning. So yeah, it will take some time, but basically nothing much. It's just to ensure that count increased by 1. So it was 0 upon deployment, and after deployment, so 0 count is coming from here. Remember, in our last session, we covered 0 count, and after the 0 count, we want to increase count by increase counter in 100, and basically we want to assert that count 1, count 2 equals to count 1 plus 1. So yeah, so this passed. So I'll collapse this and move on to the next test. So which is emitted increased event. So yeah, so we also want to do this. So yeah, so this test is well commented. So we want to check that for this increment, we are emitting this increased event. So basically, how we're going to test that is simple. So we're going to do. So I'm going to just make things a bit fast. Just copy this guy. Do SM Forge test, then run this. Or to make it clear, run it. Yeah, there might come now. I'll run it again. So yeah. So yeah, so that's how we will test for emitted events before we proceed to the next logic, which is in this case testing all of this is working appropriately. So we're going to be performing some transfers, and we're going to be covering that in the next test case. So to make it a bit faster, so I think I maybe copying and pasting it and I explain it so that we're fast, so that we don't waste much time. So yeah. So yeah, so this passed. I've seen it. So want to test for want to test a case where the stack token, the counter contract, let's say transfers. So we want to ensure that our stack contract transfers stack to caller when count is a win number, right? So remember, when counter is a win number, so our counter in this case it has a state variable called win number, which is set to 10. So we want to ensure that each time somebody calls this function, right, automatically increase count when it matches 10. So anybody that calls at the time should get some stack tokens, all of the balances, right, that were earlier initialized when the contract was created will be sent to the person. So yeah, so I have a util function here called stack, get stack token balance. So I will be kind of like, so make things a bit fast. So nothing really much, so just to copy paste it while I explain. So how about you deploy util function? So we're going to also have our util function to get balance, right? So yeah, so what it's doing is we get an instance of our ERC20 token, and then we're calling the method balance of, and we're returning it because we're specifying in this function that we want the U256 value of value, right? So yeah, so this is of type U256. So every time we call this function, use2 function, we pass in an account, it returns the total tokens within that account we're passing into that function. So yeah, so we'll get the balance of, we're calling the balance of method of the ERC20 token. So we want to explain what is happening here. So yeah, so remember in all of the test cases we've covered so far, none of them have gotten to this point where we are considering what is happening here. So we want to get the address of the caller. We won't get the address. We initialize the stack token by passing this ERC20 token dispatcher with the address of the token, and we want to call balance of. And if the balance of this particular contract with the sent 5 stack tokens is greater than 0, which is the case now, I want to capture that this works, right? Transferring all of the total balance, the 5 stack tokens, to the caller. So that's what we're going to do. So I'm going to explain. So every time I want to make sure that our validations are valid, right? So we want to make sure that we have a test amount here, right? So we're going to deploy this contract with this amount 9. So that means the next increase count is going to be 10. So yeah, and we want to make sure that we validate validate counter contract balance. Contract stack token balance. So yeah, so we want to make sure that this is valid. So we want to get the stack token balance of our counter contract, and we want to make sure that it's 5 stack tokens, and basically that. So yeah, so we simulate call, making sure that who is calling our counter contract is the user 1, right? So, and also this line is very necessary because we want to remember we are making a call, because this is saying transfer from the caller. So that means the only person that is valid to make this call here is the stack, is the counter contract. So we must add this line, otherwise this test will fail. So we're simulating that the call to this contract, the call to the stack token, remember this is now stack token, right? We're doing stack dispatcher, which is the stack token to transfer. So basically you must simulate a call to stack token, and you must specify the caller here. The caller in this case is our counter contract. So basically that I want to make sure that our assert is valid. So that means is 10. So at every point we want to validate all of the logic in our contract, right? So we want to make sure that the win number is 10. And then before that, we proceed to perform the state changing function, in this case, our increase counter. So yeah, when we do all of this, we should be good to go. We stop mocking. Remember, we're mocking 2 things. We're mimicking that we are making a call to the counter contract. That is, user 1 is making the call to counter contract. I want to stop this. And we're also mimicking that, simulating that there's a call to our stack token contract by the counter contract, right? So yeah, so that is the counter contract is going to enable the call of the transfer function of our stack token in our contract. Otherwise, this thing will fail. So we want to terminate it here, and we want to kind of like make our assertions here to make sure that we are getting the count, that the count increased, and we are checking two things, right? The principal entities in this case, right? There's a transfer. That means the sender and the recipient. We want to check the state of the sender and the state of the recipient. In this case, we want to get the balance of the sender, who before now, the balance of the contract, our counter contract, who is the sender, right? Before now, had 5 stack tokens. Remember, we specified it here that our counter contract had 5 stack tokens, and here we are saying that after transaction, so the post increase counter where win equals to 10 should enable the transfer of all of those stack tokens to the recipient, in this case, the user 1, right? So yeah, I'm going to make sure that this is our error message that throws if this is not true, right? And on the other hand, we want to make sure that the recipient, in this case, who before now had 0 stack, right? So I think, did I check that? So yeah. So we want to also validate this. Want to also validate this. So want to validate user 1. So sorry. So I'll add this user 1 stack balance 1. So stack balance 1. So we want to make sure that it is 0 and has 0 stack balance. Check if user 1 validate user 1 stack token balance. So yeah, so we want to make sure that this guy before the call had no stack tokens, and after the call he now has so yeah, okay, yeah, so are we validating this? So we should validate this, so we assert that counter balance 1 equals to stack amount. So before the call has 5 stack. So yeah, check if counter contract has, so yeah, so the two entities in this case, the sender who has 5 stack balance and the recipient who has 0 balance, right? So after the call, we should make sure that the opposite has happened. So the recipient, in this case, the user 1 gets all of the 5 tokens, and the sender, in this case, the counter contract gets 0 balance, right? So we want to test this by calling test increase counter. Yeah. We want to make sure that this is working. So yeah, all of this should work. It's going to take some time to compile. If it fails, we fix it and know what's breaking and move on to the next one. So tested for emitted events. So mind you, what we're testing here is to make sure that if new value equals to win number, right? If in the event we increase count from 9 to 10, and the latest counter value is equals to the win number, in this case 10, then the caller, in this case, user one, should get all of the stack tokens in the counter contract, which is what we're trying to test. So basically that. So yeah, so running the tests and should, wow, invalid counterbalance. So yeah, so let's check. Invalid counterbalance. So yeah, so where are we getting invalid counterbalance? So yeah. Validate stack token. Okay, yeah. Counter should have stack amount, which is fine. So which of them is which? Invalid user one balance and invalid counter balance. So yeah, let's check and see. So validate stack token balance. So we're getting the address of the counter. Oh yeah, so that's wrong. So something is happening here. So not this guy. So we're going to say user one. So yeah, so that's why. So this is the address of the user one. And also I always want to make sure that my cleaner is clean. So yeah, I think this makes sense. Yeah, so that was why it failed. I think this should pass now. So yeah. So run the test. I think this should pass. Yeah, it's passed. So move on to the next one, which is we're going to test. Remember, we're just testing if everything works and there's stack token in the contract and the balance is greater than 0. Then we should proceed to do this. And plus, sorry, there's stack token in the contract and there is the new value is equals to 10. So this should transfer all of those stack tokens, right, respectively. So yeah, so we should also check this. How about in a case where we don't have stack token, right, in the contract? So what should happen, right? So this should not work. So count should just increase without any stack token transfer, right? So basically what we're going to be doing is to make sure that that is valid. So we're going to check that. So if there's 0 stack, so what should we do? We should ensure that if we have 0 stack, so yeah, so if there's 0 stack, we just tested for when there's stack and an increment, right? So yeah. So I'm going to be creating a util function called transfer stack. So it's kind of like easier for us to perform transfers, right? So what I'm going to do here is to create a util function called transfer stack. So yeah. So yeah, so I'm going to create it after my deploy util. So I'm going to get balance. And then yeah, so transfer stack. So I think I can call this transfer stack within so I can just do transfer stack. Instead of doing all of this, just do transfer stack. Then the caller in this case is stack holder. Then recipient is the contract address. So we kind of like modularize. So yeah, so we're going to pass in this. So just to make it consistently clean, so we just remove all of this here. So yeah, so it's kind of like a cleaner way to modularize our code and make it clean. So we're just calling this. So basically, remember, every time we call the transfer, it returns either a Boolean. So if you hover over it, you see that it's returning a Boolean. So if it's true, then it was successful. If it's false, that means the transfer was not successful. So yeah, so basically how we're going to be modularizing our code. Yeah. So the next thing we're going to do is to, I think, has 0 stack. So we're going to collapse this. So for each we test that is successful, we collapse it and then move on to the next. So in our own case, we're going to be testing that what happens here. such that if there's zero balance, right, in the counter contract, that means we should not proceed to transfer any stack token to the caller, right? So yeah, so we're going to do something here. We're going to, because it's yelling at us here in line 256. So we're going to create a constant, and the win number is 10. So we're going to kind of okay, we're going to create a const win number equals to of u 32, and it's going to be 10. So yeah, the win number is 10. So what we're going to do here is simple. I'll walk through what's happening here. So basically, because of time, to kind of like cover a whole lot. So yeah, so we want to ensure that when we deploying our contract, it is set to 9, and we're getting the current count, and we are asserting that the count is equals to 9, and we're going to get the we want to get stack token balance, stack token balances of what? Of the caller and what? The counter contracts. So yeah, so basically what we're going to be checking. So in this case, we're checking for the counter contrast stack token balance to make sure that it has 5 stack tokens. I want to also check that we're going to say let, because in every transfer scenario, we're looking at the sender and the recipient. So yeah, in our own case, we're looking at the stack token of, let's call another account, right? Let's say we want to check the owner, right? So yeah, so let's say let owner stack balance 1 equals to get stack balance, and it's going to be owner. So I don't want to use the user 1, because there's a scenario here. What if, for instance, something happens and we kind of like transferred all of our stack token to another account? So we have another account that we want to kind of like simulate who is the owner, right? It may not necessarily be owner, it can be anything. So you can call it user 1, user 2, address 1, address 2, anything as the case may be. But in my own case, I'm specifying that this is the account that I want to transfer some stack tokens even before let's say so on deployment, I have 5 stack tokens, and before count gets to 9, there's no more. So for instance, something happened and stack tokens was transferred out of the counter contract, right? So if it gets to this point, should we still proceed to transfer stack token to the caller? No. So that's what we want to simulate, right? So yeah. So we're going to assert that owner stack balance 1 equals to 0, because at this point no stack tokens, invalid owner stack amount. So yeah, so this should be 0. Then afterwards, we want to transfer all of the stack tokens, right, from the contract to the owner, right? So in this case, we only have 5 stack tokens. Remember, we're validating that the counter contract has 5 stack tokens, and here we're validating that we want to make sure that we have transferred all of these stack tokens to the owner. I want to validate that it was successful from counter to owner. So yeah, that stack transfer was successful from counter contract to owner. So yeah, so what we're going to do is to have this assertion, and then want to validate that after this transfer, that at every point we're going to be validating. So before any state change transaction, what was the case? After state changing transaction, what is the case? So yes, that's what we're doing. So after this stack transfer, we're transferring out all of our stack. So remember, there's a sequence. On deployment, we have 5 stack tokens. For some reason, we want to kind of like simulate a case where we don't have stack tokens again in our contract, in our counter contract. So we're transferring all of our stack tokens to the owner, which is a different account, and that's what we're simulating here, right? I want to assert that the owner truly has received all of the 5 stack amount, and that is why this validation is here in line 250 to 250. And then want to kind of like simulate a transaction call to the counter contract using this start cheat caller address cheat code, right? And we're going to say passing in this address as the caller of this method. We're going to call a state changing function, in this case, increase counter. So, and we also want to make sure that our validate win variable, state variable is valid and it is 10. So yeah, so that's that. Then we proceed to execute our state change, which is in this case increase counter. Afterwards, we terminate call to the counter contract because we want to take a snapshot of what has happened and assert that all of what has happened is valid. So yeah, so we want to assert that the new count, which in this case should be greater than, so let's say the count 2 should be test count plus 1. Test count plus 1. So yeah, that means it's 10, right? And if not, show this error that count 2 was not set. And I want to make sure that no token transfers in this scenario, right? So in the case where the counter contract has 0 stack balance, there is no contract transfers, right? No stack token transfers. So basically that's what we're checking here. So yeah, so validate this, and basically the 2 entities, in this case, the sender, the recipient, kind of like have their corresponding token balances the same, right? Then forge test. So we want to make sure that this is passing. So yeah. So while we wait for this to pass, we're getting ready to test our decrease counter. Afterwards, we'll make sure that we proceed to reset counter, and that will be that. And we're making remarkable progress here. So yeah. So in all cases, for every transfer, token transfer, probably any value in this case, whether stack, whether it's any assets, right? You want to make sure that you want to write an assertion for before and after, right? So at every point you're mimicking state change, you're making sure that all of the things that happened before the state change and after the state change are well validated. So basically that's the idea, right? So yeah, and you must also make sure that you add this this attribute. So yeah, it passed. Yeah, it passed. So we're going to move on to the next item, which is testing that. I think I'm going to collapse this. Yeah. So valid test passed. So we're going to test that. So in addition to this, we're going to have this line there. taking a snapshot of the last block and basically testing it to make sure that it works. So yeah, so I'm going to test this. Then forge tests, and I'm going to test. And basically this, and let's see, hopefully this should work, because nothing really much changed in our decrease counter functions. So yeah, our decrease counter, nothing changed. We've tested it before. So just to specify the fork attribute, the test, I think that should pass. That should pass, and we should proceed to the reset counter. So yeah, pretty much. We should test this. Remember, we're also testing these. So yeah, so we should also test this. Nope, not this. So we're testing, we're adding this attribute, the fork attribute. Remember, this fork attribute must match what we have in our configuration file. That's our scarp.toml, right? So we must specify that our mainnet, the name of the fork, right? In this case, our mainnet, and we're specifying the RPC URL and the corresponding block ID tag, which is in this case latest. So you must specify that and use it in your fork attributes. Otherwise, the test will not pass. So yeah, this passed. You can see that our tests, save panic decrease counter worked. So I will collapse that. So let's test this to make sure that it's working as intended. I think when we test this, we can see the same forge. Then I think I need to have to run this like this. So so the only thing we're going to change is this, because we want to change this because our decrease counter test successful. Okay, yeah. Okay, I think no, I think this should work. Decrease counter. Yeah, so these are the negative cases for what should not happen for the decrease counter. Remember, our decrease counter is specifying that if the current count is 0, we cannot decrease below 0. So that's the error here we're trying to throw. So we've covered this in the last session, so you can actually reference that video. Not doing anything more, just to run the test and see how it works. So cover this, then I'll proceed to not this, proceed to cover the reset counter. So I want to add this attribute. So yeah, I think this is the only test that should change, because we are not considering only owner for reset. So yeah, so that's basically that. So yeah, so let's go back to this test. So we're testing this. We're testing. Oh yeah, so sometimes you can have this. So always make sure. So this is kind of like an error. So you want to kind of like run SN forge. So it's kind of like normal for you to come across this. You want to do clean cache. So yeah, run this. So should. So this is the error. So want to run the test again. So whenever you come across that error, you use the clean cache to kind of like recreate the whole test runner, and it kind of like makes it fast and not kind of like probably run into such errors. Yeah, so we can see that we want to run the tests. Take some time, but definitely it passed. Yeah, you can see that our test panic decrease counter worked. So that is a big pass for this panic decrease counter. So this passed. So we want to test this, and we want to add this tag to it. So yeah, so basically this so yeah, so we want to check for successful decrease counter. So that means if we have count that is greater than a particular number, let's say we have count set to 5, we want to kind of like test that our decrease counter work. We have covered this in the last test, so yeah, just to test that successful. Let's check. So yeah, so let's check this. So yeah, this should work. So afterwards, after this, I think we're going to test for emitted events and then test for, I think basically that. Test for reset counter. Taking quite a number of time to run, but basically that's how such tests work with SN Forge, unless there's kind of like an improvement in the future. But currently that's how it works. So yeah, so how we work to make all of our tests pass is the core focus of this session. So make sure that you simulate the instances that, based on the logic of your contract, that these instances are kind of like captured in your test. So I'll be going through them one at a time. So so I think we can actually cover reset counter. Let's go over reset counter while we wait for this test to pass. So one of the things that we notice here is that we will see that our we're having a reference of our stack token, and then we're calling get balance of. So we're saying that if the balance of the stack token is greater than 0, at the time we want to call this reset counter. Mind you, there's no access control here. There's no access control check, meaning anybody can actually call this reset counter, right? And when it's deployed, anybody can actually call it. So it's open to anybody to call. So the only provision here is that once the contract balance is greater than 0, as a caller who wants to reset the counter value of this contract, you must kind of like transfer some assets, some tokens, right? So the total balance of this contract, whatever the total balance is, whether 5 stack tokens, whether 10 stack tokens, you must provide that as the corresponding stack value before you can actually write to it. That is in the event that we have some stack tokens in this contract, right? And that value is greater than 0. If it is 1, you send 1 stack token to reset it. If it is 2, you send 2 stack tokens to reset it, like as the case may be. So that's the only provision here. So yeah, I don't know why this is taking. Okay, yeah, it passed. Yeah, nice. So yeah, so we'll move on to the next test, which is we've tested for successful decrease counter. We're going to be considering the next one, which is decrease event, so like counter event. So if this event was emitted, right? So we're going to test for this. We're going to say SM forge test. I'm going to check for this. Okay, I think I need to clear my terminal, then run it again. So yeah. So yeah, I think this is the only test. Then we kind of like I think there's no need for these tests because there's no owner here. There's no access control, right? So we're going to remove that and test successful counter. So we're going to kind of like, I think that's the next test. So test successful reset counter. So that means anytime somebody successfully resets the counter and balance is greater than 0, we want to see what happens, right? So kind of like so tested this, glance that. So all of these tests. So yeah. So yeah, that passed. So emitted events passed. So yeah, so we are going to focus on so emitted decreased event passed. So we're going to focus on this. And again, we don't have access to, it's yelling at me. So because of time, we'll just quickly copy and paste some this approve stack token. So it's a util function to enable us to, because for us to call the transfer from function of our ERC20 token. So ERC20 token transfer from, for you to transfer, call, probably have a third-party contract spend your token on your behalf, you must kind of like approve first. So that's why we're having this approve here, right? So we're going to kind of like approve because in our contract, we are saying transfer from, that means the caller must have given us some degree of, we have an allowance to spend the person's token, right? So yeah, so we want to do that. And so before you call transfer from, just to be clear, you must first of all approve the spender to some tokens, right? So we want to call this before we proceed. So yeah, and it's also yelling at us because we don't have this reset. So we can actually, in our counter contract, we will create this enum here. So we're going to bring it down. Create instead of decrease, we're going to say reset. So yeah, so it's going to be called. So just to copy and paste. So just because of time, we don't have time. Just come here. So write to 0, then we emit this event. So instead of decrease, we say reset. So yeah. So basically, what we're trying to do here is it's kind of like yelling at us because we have not given it access to reset here. So we need to bring in resets. So we have where's our events? We have quite a number of increased. Oh yeah, so I want to counter event. So yeah, it's going to I think yeah, so I think has no variant. I think we should have this. I think I imported this event. I think this should work. When we try to compile it, then we'll see what the problem is, right? So yeah, so counter event increase. Oh yeah, so let me check Oh yeah, so I failed to add it in my counter contract. So yeah, we've created the struct, but we've not specified that this is in our enum event. So yeah, so we're going to do reset. So yeah, it's going to be reset. I'm not going to do this. So yeah, so basically it should take care of the error. Yeah, so yeah. All right. So let me do a quick walkthrough. So in our own case here for test reset counter, so we want to check something. We want to check that before we deploy, we want to set test count as 5, and that is basically that. And we're going to create a spy. So that spy event, we're going to use it to emit for our tests. We're going to do that for our test events. So when we test for emitted event, we want to make sure that our set event was emitted accordingly. So we're going to use that. So yeah, so that's one of the things we're going to do. And again, we have this we want to we have this test stack amount. This stack amount is what we're going to be using in our test here. So yeah, so we're going to be using this test stack amount. So in our own case, we want to say, all right, we want to approve our stack token to spend, let's say, let's call it 5. Let's say 5. All right. Yeah, let's say 5 stack, not 10 stack. 5 stack, 10 stack, or any one of them. So I think let me use 10 stack, so that's kind of like different. So make sure it's 18. So I think we're good. So we at every time we so I will explain what's happening here. So we want to ensure that our stack tokens in this case is kind of like we want to, before we call transfer from, we want to make sure that we have given approval for our we want to make sure that our counter contract has some kind of like some degree of privilege to spend our tokens. So yeah, so we want to make sure that that is valid, right? So that's why we're using this approve function here. So we want to approve that this user have approved our stack token to spend this amount of stack tokens, right? So yeah, we approve our counter contract to spend such that this line will work. So this line will not work if we have not been, if our counter contract has not been given approval to spend. So basically that's the goal of this test. So we have something else happening here again. We want to make sure that sorry for that. We want to make sure that we have the appropriate allowance. So approve gives a third-party contract the allowance to spend. So before transfer from is called, it's going to be checking, does this contract have, does the spender have the necessary allowance? So that's what we're checking, right? So we want to make sure that upon successful approval transaction initiated by this user one, we want to make sure that there's a corresponding allowance that matches this approved amount. So that's basically what we're trying to assert, right? And we can see that that is what we're doing in line 413, right? We want to make sure that the stack token allowance for user one giving, so you can hover over the contract, this method, to see the owner and the spender. So in this case, the owner is user one and the contract counter contract is the spender. So we want to make sure that also, so there's something happening here. If you know, before now, there's no instance of token transfer to the contract to all token transfer upon initialization of this deployment of this contract. We are sending from the token holder to the contract. But now in our own case, we want to send to this user one who is going to pose as an account that we're going to use to call this increase count, right? So that's basically what we're saying. So we're going to transfer stack token from the provider, in this case, our token holder, from the stack, from token holder to user one who is executing the transaction as a caller. So yeah, so basically that I want to make sure that this token transfer is successful. So we want to have this assertion here. This assertion is making sure that, we're getting the balance of user one, and we're making sure that it is equals to the amount that was sent, right? So which is here, making sure that that amount matches. Stack balance, yeah, so yes, that's basically what we're saying. And the next thing, we're going to check that the counter contract has 5 tokens sent. So remember, when we deploy, the stack token automatically has, I think this should come first before this. So we'll check that. I think I'll run my scarf FMT, yeah. So yeah, we want to check that the stack token has the corresponding stack amount, in this case 5 stacks, right? And then want to make sure that we transfer from the provider to the user one who is simulating the transactions. And we want to also make sure that, so yeah, so this is it, making sure that token holder successfully transferred to user one. This is the assertion. And afterwards, we're going to be simulating a transaction to our counter contract by user one by calling the start cheat call address cheat code, right? So yeah, so we call reset afterwards. Then I think afterwards we stop calling. So we perform the state change, in this case reset counter, and we terminate the call to the counter contract. That means no longer are we calling the user one, no one calling the counter contract by the user one. So yeah, so we're going to take a snapshot of what has happened right after this call, this reset counter call. So we're going to make sure that our counter was reset to 0, and we're going to make sure that the counter contract successfully received 5 stack tokens, right? Remember, it started out with 5 stack tokens that were transferred from the token holder to it before the call. So after the call, it should have stack amount plus stack amount 5 plus 5. That's 10, right? And I think we should test stack amount. You can actually, yeah, 5 plus 5, that means 10. So yeah, and we should validate that user wants, so 2 things on 2 ends. So we do our token balance validations, right? So stack token balance for the counter contract, and stack token balance for validation for the user one. So basically, we must make sure that what was sent before the reset counter, so I mean before the reset counter call, the token balance is greater than the eventual amount that was sent out. So that means 10 minus 5. In this case, stack was not deducted. I want to also make sure that this reset event was emitted, and also make sure that the increased event was not emitted. So basically that. So we run this. Before we run this, we must add this line, otherwise it will not work. So make sure you add this line, SM forge test. We want to make sure that to grab this, paste it here. So yeah, so basically that, oh yeah, so we have this error. Anytime you have this error, make sure you clean your cache. So yeah, so SM forge, clean cache. Yeah, so I want to clean our cache. And I think the latest version is clean, just clean. But this is we're using, I think this is the version of our scarf, specifying our scarf. So we're using SM4 0.37. So yeah, so I think there are higher versions of this. So in those higher versions, it is just SM4 clean. So yeah, I think while we wait for this, we will test the last part, which is in this case, we want to test we want to test a scenario where just to copy and paste that. So we want to test a scenario where in our counter contract, what happens if there are no stack tokens to be transferred, right? So if there are no stack tokens in the contract, we want to just proceed to just write the current counter to 0, set it to 0, and emit this event. So basically that. So yeah, so want to do that, right? So once this passes, oh yeah, so it's passed. So yeah, we're going to run, I think just a quick one. So to cover the last part, so we're going to make, in the essence of testing is to make sure that every logic in your function is kind of like validated. So we want to test that this is valid. So we want to test that if contract balance is not 0, is greater than 0, right? So in the what happens in the event that we don't have stack tokens in our counter contract? So we should just not ask the user to send any tokens. We just write counter to 0. So this should only work when we have any amount that is greater than 0. So yeah, so we're going to write a last test case. So we're going to add this. So basically what we're saying here is that test reset counter when counter contract stack balance is 0, right? Test reset counter, right? So we should test that if it is stack balance is 0, there will be no stack transfer from the caller to the contract, right? So yeah, so basically that. So we want to make sure that that happens. So yeah, so this is the validation checks. So we're validating that. Remember, this validation is very necessary, making sure that counter is 0, sorry, is 9, and we're getting the balance of the counter address. So this is what I'm saving it as, so right. So we're checking this and making sure that I think we should also check the balance of stack validation checks. So stack validation checks for counter and user 1, who is the caller. User 1. So user 1. So user 1. So in this case, we're going to say let user 1 stack balance. So this is the balance before the reset counter was called. So we want to make sure that we get stack token balance of user 1, making sure that user 1 stack token balance is 0, right? So assert that user 1 stack token balance equals to what? 0. That means invalid user 1 stack balance. So yeah, so we should also check that the balance of okay, so I think our counter first. So yeah, and also check if user 1 has 0, so yeah, 0 stack balance. So we'll make sure that this happens. Then we simulate an increased counter call coming from user 1. Probably for instance, let's simulate a case where before this happened, so probably user 1 increase count from 9 to 10. That means user 1 at this point has some stack tokens, right? So yeah, so user 1 has gained some 5 tokens. So and afterwards, user 1 wants to call again when stack. When when there's no available balance of stack in the counter contract. So basically, that's what we're trying to check here, right? So yeah, so we want to check that. So we want to increase count, then terminate the call, making sure that the assertions work, checking that the balance of user one and the balance of the counter has increased accordingly, right? In this case, the stack token balance of the counter contract should be 0 because user one has increased counter to 10, and the transfer of stack tokens from the counter contract to user one have taken place, right? Was successful. That means the counter contract has no stack tokens, right? And user one has received the 5 tokens. So afterwards, after receiving these stack tokens, user one will kind of like proceed to reset counter. In this case, there are no tokens in the counter contract to reward anybody to trying to so no, what am I saying? So there's no counter, there's no stack token balance to, I'm sorry for that. I think there's no counter, there's no stack tokens in the counter contract. Yeah, so there's no counter tokens, there's no stack tokens in the counter contract. So if that happens, then there's no stack token transfer, right? Not from any party, right? The recipient is not, there's no recipient, there's no sender. So we just proceed to just increase count without stack token balance changes for both parties, right? The contract address of the counter contract, and in this case, the caller, in this case, user one. So basically, no state change for the stack token balance. So that's what we're trying to assert here. So, right, we have 2 entities. The caller, in this case, user one, will only have his stack amount, which he got from the first call, right? Which he got from the first call, which is here. So yeah. So this is it. So anything after that, nothing should happen. So everybody's stack token balance remains unchanged, and then increased from 10 to 0. And that is basically what we're trying to assert here, right? I want to also assert that the event was emitted, right? So we will add this by event. So yeah, so before any state change, we'll add this by event and get count, like add this by event. And also want to grab this and making sure that it's a successful count event that was emitted. So basically, we want to validate that user one balance is unchanged after reset count transaction. Yeah, so I want to format my code, and also I want to test. So reset count when counter test reset counter when test reset counter when counter, okay, can you set reset counter? Yeah, so test reset counter contract sends, okay, yeah, is 0. Okay, test counter contract receives no stack token when stack balance is 0. Yeah, so I think this is a proper one. So yeah, so I will do this. I'll do SN forge, test, paste this, and let's see, should work. And So yeah. Um, so yeah. So we should be wrapping up when this compiles. Um, so the transaction we should call from one as color. We said to set transaction. So yeah, stop mocking the color to clean all the test context. So yeah, so all of this should work. So want to make sure that this scenario where the caller is expected to send some stack tokens to the counter contract is not supposed to be in the event that there is no. Okay, yeah. So let's see. Why did it fail? Oh yeah. So yeah, let's check. Oh yeah, I think it passed to this point. Hmm. I think it should work. So yeah, I think this will work pretty much. So both balances remain unchanged, and that should be the context of this assertion, and that should be all. Oh yeah. So I think we should remove this and use variable. So yeah, it passed, and I think with that we'll come to an end of the tests. So the core goal is to make sure that all of the logic of our counter contract has changed in the last session were are captured in this session. So I think that's all. So thank you so much. I think you had fun. If there are issues, feel free to ask on Discord. The assignments we come on accordingly. So yeah, so you can actually play around with it and see if you can actually test more and see what you can capture as, but I've captured basically everything, but see how we can actually explore this, tweak it a bit and see, probably add access control to reset counter, and so probably some decrease counter. So kind of like play around and see how you can actually add some advanced concepts here. So probably not stack tokens, can actually check for it and that. So scenarios like that to make you understand better concepts. So yeah, so that's that. And I hope you had fun. I had fun too. Thank you.